This video introduces the project RoboEXP, Action Conditioned Scene Graph via Interactive Exploration for Robotic Manipulation. In this work, we propose the task of interactive scene exploration and design our RoboEXP system to tackle the challenging task. Imagine a future household robot designed to prepare breakfast. This robot must efficiently perform various tasks, such as fetching food from the fridge and gathering utensils from drawers. Key to its success is the ability to interact with and explore the environment. Such ability is also essential for practical robotic deployment in environments like household and offices, facilitating their everyday use. Now we show an example of the interactive exploration process for the tabletop environment and illustrate how to leverage our constructed action-conditioned scene graph for downstream tasks. In the process, our system perceives the environment from different viewpoints and constructs corresponding memories. Then, the decision-making module guides the robot arm to interact with the environment to further reveal the objects. Here, the robot arm opens the doors and drawers to see what's inside, and the scene graph is updated correspondingly. Leveraging the constructed scene graph, the robot is asked to make the table, and it can naturally know the exact position and the list of actions to fetch the objects. For example, for the fork, it knows the exact drawer it needs to open. Also, for objects not in the scene, it can precisely identify them and ask for help from a human. The following video shows 3 different aspects of interactive exploration involving recursive reasoning, obstruction handling, and human intervention. The first 2 scenarios demonstrate the recursive reasoning ability of our system through the interesting Matryoshka dolls. The first scenario involves 5 nested Matryoshka dolls. Our system is able to explore the dolls automatically. Meanwhile, the scene graph is updated to capture the action logics. After exploration, our system will restore the scene to its state before the exploration. The second scenario further involves the deformable object, fabric. Our system is capable of exploring soft objects both in decision-making side and action side. Beneath the fabric, there are 3 more nested dolls for our system to fully explore. After discussing the recursive reasoning ability of our system, we will now address its capability to handle obstruction cases. In this scenario, there are 2 cabinets on the table, with 1 condiment blocking the left door of the white cabinet. The verifier role of the decision-making module enables our system to handle such obstructions. The system moves the obstruction to idle space first, then after exploring, it moves it back. In the graph, the precondition of the open action is updated with the pick operation of the condiment. After demonstrating how our system deals with the obstruction case, we will illustrate how our system is robust in scenarios involving human intervention. In the first scenario, the robot needs to explore the white cabinet with 2 doors. However, during the exploration process, humans add or remove objects from the scene. Here, the human removes the orange from the left door and puts a Coke into the right door. Our system can adaptively re-explore the corresponding doors through monitoring human hand interaction. The corresponding high-level graph is also precisely updated. The second scenario highlights our system's capability to adapt to significant changes in the environment. This time, a human adds a cabinet to the tabletop environment, and our robot arm can automatically detect the change and explore accordingly. Additionally, our action-conditioned scene graph is updated to show what's inside the new cabinet. Using the complete action-conditioned scene graph, our robot can perform the task of collecting all fruits in the environment. It can precisely determine which drawers to open to fetch the fruits. The following 2 videos demonstrate the effectiveness of our system on the interactive exploration task using a mobile robot in 2 household scenarios. The first scenario features a subscene with a sofa, a table with items on it, and a cabinet with an apple hidden in the top drawer. Our robot can automatically explore all the hidden spaces in the cabinet and construct an accurate action-conditioned scene graph. The second scenario includes a coffee table with a flower on it, 2 chairs, and a cloth on 1 chair with an electric reader under the cloth. Our robot can find the hidden reader with the guidance of our system. Thanks for listening.